be going over some questions that you all asked on this third quarter test review, number one. The three questions are number 17, 27, and 33. So I'll start on number 17. And number 17 asks us to, using what we know about multiplicities and end behavior, sketch a graph of the following. And this is the one that we're talking about here. So the first thing that I notice is that this is all in factored form. So if I were to set each of these factors equal to 0, I would get my x-intercepts. So my first x-intercept would be 0. If I set my next factor equal to 0, I'd get 3. And if I set my third factor equal to 0, I'd get -2. Something I notice about -2 is that factor happened twice. So that means it has a multiplicity of 2, or what it means for us on the graph is that it's going to bounce off the graph. So I'm just going to put these 3 dots on here. We've got 0, 3, and -2. I also want to look at end behavior. I want to see what's happening on the right side of my graph and on the left side of my graph. To figure out what's happening on the right side of your graph, we are going to look at our leading coefficient. And our leading coefficient is just a 1 in front. Most importantly, it's a positive 1. Because the leading coefficient is positive, on the right, my graph is going to go up. It's going to look like this. To determine what's happening on the left, I'm going to look at the degree, which is my highest exponent. I have to imagine that I multiplied all these factors together and see what my highest exponent would be. If I multiplied them all together, I would have this as an x squared, x cubed, x to the 4th power. So my highest degree, or my degree, is 4, which is even. So it's going to do the same thing on the left. If it was odd, it would do opposite on the left. So on the left side, it's also going to go up. Now, we have got to figure out what happens in between here. Well, remember, at -2, it was supposed to bounce off. So it's not going to cross through. It's going to actually bounce off. Come back down. At 0, it's going to cross through. And at 3, it's going to cross through. And my graph looks similar to this. I'm not perfect in how high and how low I'm going in between, but right now we're just worried that you can see the shape of this graph. So that was number 17. The next one I'm going to do is number 27, which was a graphing problem. And 27 is a rational function that we're going to be graphing. So 27 looks like this. And we're asked to find intercepts and asymptotes. So for my y-intercept, I go in, and wherever I see x, I put in 0. So for y-intercept, I would say y equals 0 squared, 3 times 0 minus 10, divided by 0 squared minus 9. All of that is going to come out to a positive 10/9. So my y-intercept is going to be 0, positive 10/9. My x-intercept, I am going to factor, actually I'm just going to set my numerator equal to 0, but I'm actually going to put my numerator and denominator into factored form, just in case I need this. So the numerator factored is going to be x plus 5, x minus 2. My denominator, x plus 3, x minus 3. To find an x-intercept, I set my numerator equal to 0. So if I set my numerator equal to 0, I get 2 x-intercepts. I get x equals -5 and x equals 2. So -5, 0 and 2, 0. Vertical asymptote. For the vertical asymptote, we're supposed to set our denominator equal to 0. So if I set my denominator equal to 0, I'm going to get x equals plus or minus 3. For horizontal asymptote, this is where we look at the degree of the numerator, the degree of the denominator. In this case, they're both the same. So when they're both the same, it is y equals the leading coefficient over the leading coefficient, y equals 1. So now I'm going to come over to my graph and put all this stuff on here. My y-intercept is 0, 10/9, so that's a little bit above 1. I also have -5, 0, and 2, 0. I have asymptotes, vertical ones at -3, Remember, vertical asymptotes are like walls. You cannot cross through them. And my horizontal asymptote is y equals 1. You are allowed to cross through your horizontal in the middle of a graph. The purpose of the horizontal is to tell you what happens way out on the left and way out on the right. Okay, let's use our asymptotes to help us. I don't think we're going to have to use this table at all. I have this point right here. If I'm going to use those red asymptotes to help shape my graph, it's going to look like this. In between my vertical asymptotes, we talked about in class that our choices are parabola up, parabola down, squiggle up, or squiggle down. That is typically what our graphs are going to look like. Well, I know if I have these 2 points right here, I'm going to be a squiggle down. The reason that I cannot be a parabola down is because if I turned it into a parabola down, it would cross over the x-axis, and I didn't have any more x-intercepts listed here. So please don't make your graph cross over the x-axis if you don't have any more x-intercepts. I also need a part of my graph over here on the right. It's either going to be up top or down below. It's got to be up top, and the reason that it can't be down below, if it was below, again, it would cross the x-axis. Remember, we did not list any more x-intercepts, so it can't cross over. So this is what the graph looks like. If you were unsure, you could always use your table and pick some x values and plug them back into your equation to find some y's. Okay, and the last problem that you guys asked me about was number 33. Number 33 was solving a rational, meaning fraction, inequality. So when you have something like this, the first thing we want to do is bring everything over to one side. So let's bring it all to the left. 5 over x minus 3 minus 3 over x plus 1 greater than or equal to 0. Then I need to get a common denominator. So, focus. My common denominator is going to be x minus 3 times x plus 1. So I'll multiply top and bottom by x plus 1. Over in this second fraction, I'm going to multiply top and bottom by x minus 3. Then I'll write it. My purpose of the common denominator was to be able to write it with just one denominator, x minus 1, x plus 1, x minus 3. My numerator, I'm going to distribute my 5. So 5x plus 5. In this second fraction, be careful when you're distributing. Make sure you're distributing the negative 3. So negative 3 times x is negative 3x. Negative 3 times negative 3 is plus 9, still greater than or equal to 0. I'm going to combine up like terms here. Up top, 5x minus 3x is 2x, and 5 plus 9 is 14, over x plus 1, x minus 3, greater than or equal to 0. At this point, the purpose of getting it down to here is to find our critical numbers. So I'm going to come up here for a minute and list what my critical numbers are. My critical numbers come from setting the numerator equal to 0. If I set the numerator equal to 0, I get negative 7, and then also setting the denominator equal to 0. So negative 1 and 3. Then I take my critical numbers and I put them on the number line. I start with the smallest one, negative 7, negative 1, and 3. And then we pick some test numbers. So for my test numbers, I pick anything smaller than negative 7, maybe negative 8. In between negative 2, 0 is always a good one to pick, and maybe 4. The test numbers are going to go back in anywhere where I see a 0 on the side. This looks like the most simplified form to put it into. So I'm going to put negative 8 in. Well, 2 times negative 8 is negative 16, plus 14 is negative. Negative 8 plus 1 is negative. Negative. All of this, when I simplify, is a negative. Put negative 2 in. So this is negative 4 plus 14, positive. If I put negative 2 down here, I have a negative and a negative. That all is going to be positive. Put 0 in. Up top is positive. On the bottom is positive and a negative. All of that is negative. And lastly, we'll put 4 in. And if I put 4 in, I get positive over positives or positive. Now, to determine where my answer is, whether my answer is the positives or the negatives, I am going to look back at this symbol right here. This says greater than or equal to 0. Numbers that are greater than or equal to 0 are positive numbers. So my answer is going to be here and here. Last thing I need to do is to decide if I should close these circles in. Well, there is an or equal to sign, so I do have to consider closing things in. But remember, anything that came from the bottom, -1 and 3, -1 and 3, have to be open circles. Anything that came from the numerator, we're allowed to close in. And again, the reason behind that is because anything from the denominator would make, if I plug it back in, it would make the denominator 0, and we're never allowed to divide by 0. So I'm only allowed to fill in -7. My final answer in interval notation would look like this. Bracket, -7, comma, -1, parenthesis, and parenthesis 3, comma, infinity. I hope that helped. I will also be posting the entire answer key as well as review number 2 this week.